As you are familiar with the electrode potential now, you know that what the tendency of an electrode to gain or lose electron is electrode potential, right? And the one which has a tendency to lose, oxidation electrode potential, and the other which has a tendency to gain electrons, that means the reduction electrode potential. Moreover, you also know that the electrode potential value depend upon three factors, out of which one is the nature of the metal and or the ions, second the concentration of the metal and the ions, and third is the temperature, right? So it is clear that electrode potential definitely depend upon the concentration of the metals and ions and also on the temperature. So that means we need to have the value that is the standard electrode potential, that means the electrode potential which is measured at standard condition. So it is it will be fine to call electrode potential as standard electrode potential, right? So standard electrode potential means the value of electrode potential which is calculated at standard conditions, that is at 298 Kelvin for 1 molar concentration of solute. So if you get to see electrode potential, that means the electrode potential at of a given element, right? But if you get to see the standard electrode potential, that means the value of electrode potential at standard conditions, that means 298 Kelvin and for 1 molar concentration of solute, right? So this is standard electrode potential. Moreover, you should know that it is not easy to calculate the absolute value for the electrode potential. I repeat, it is not easy to calculate, or you can say you cannot calculate the absolute value for the electrode potential. The reason being, you are aware that the half cell reaction do not take place independently. So how we can calculate the absolute value for this thing, the electrode potential, right? As we know, the half cell reaction do not take place independently. There need to be a couple present, that means there is a need to be two beakers present, two half cells present in which the oxidation and reduction will occur. Then only we can have the the value. That means we cannot have the accurate value for this electrode potential, right? Because it is a relative tendency. We can just compare that this has a tendency to get oxidized when we compare it with this, or we can say it has a tendency to get reduced if we compare it with it, right? So that means it is not easy, or you can say it is not possible to calculate the absolute value for the electrode potential. The reason being, one, the half cell reaction do not occur independently. The second, it is a relative tendency that we need to relate it to some other electrode, right? Then we can know the value. That means yes, it has a tendency more to get oxidized when we compare it with it, or we can say it has a tendency more to get reduced if we compare it with it, right? So that means the absolute value, not at all it is going to be, we cannot calculate in any case, right? So now the question is this: how we are going to calculate the value of electrode potential now? Or how we are going to know that yes, this electrode is going to act as a cathode in this couple, or it is going to act as an anode in this couple? As I told you, it is not compulsory that if one electrode is acting as a cathode in this example, it will be definitely acting as a cathode in all the example. It is not like that, right? So that means there is a possibility that if electrode act as a cathode in this case, it may act as an anode in that case. So that means it will create a confusion, and how you will come to know that which the cell you are going to use as anode, or oxidation half cell, or which cell you are going to use as reduction half cell. So in order to come all these confusions, or just to make you well versed with the topic, I may tell you, and you may be curious to know this, that how this electrode potential is calculated, or how you just decide that this is going to act as anode or cathode in whichever case we are talking about. So that means if we want to know that this electrode is going to act as oxidation half cell or reduction half cell, we need to know its electrode potential. It is clear that we need to know the electrode potential value, and after knowing the electrode potential value, it will be clear that it is going to act as anode or cathode. Now, how we are going to calculate the electrode potential value? The question is this now, right? This is clear that we need to know the value of electrode potential, then we will be deciding accordingly that it is going to act as anode or cathode, right? You are clear with it. But the question is that how we are going to just know the electrode potential value. So it is so simple. In order to calculate the the electrode potential value, we need to have a reference electrode, or that means we need to have SHE, that is the standard hydrogen electrode, which act as a reference electrode. Here I have for you, it is SHE, or it is called as NHE. This is a reference electrode with the use of which we can calculate the electrode potential of any cell which we wish to, right. So what is this SHE, right? It is clear, it is a reference electrode. It is clear to you that it is called as a reference electrode, and what is its use? It is also clear to you. The use is that it is going to give the electrode potential value for the different cells. Now let us see what this SHE actually consists of. See, it consists of a beaker. It is just clear to you. It has a solution. This solution is 1 molar HCl solution. This solution is 1 molar HCl solution, right. This is a platinum wire, right, to which the platinum foil is attached. There is a tube, right, through which we are bubbling the hydrogen gas, right. I think this SHE arrangement is clear to you. Again, a beaker, HCl, 1 molar HCl solution, a platinum wire, and can be a copper wire as also, right. A platinum foil attached, and the hydrogen gas is just bubbled through it. Now, what information it is going to give us, or what changes it is going to show when it is connected to any kind of cell, right. So if we use this reference electrode to calculate electrode potential of any other cell, then what happens? If it acts as a anode, because it also there is a possibility that it acts as a node on connecting to another cell, or it may act as a cathode, and accordingly the chemical reactions are going to take place, right. So if it acts as a anode, then what is going to happen? Obviously it is going to undergo oxidation. You know that in case of electrochemical cell, the one which acts as an anode undergo oxidation. So same is applicable to this case, that if it acts as a anode, obviously it is going to undergo oxidation, right. So this is what I am showing here with the reaction. Oxidation means we have a hydrogen gas. It will lose 2 electrons and it will form 2 hydrogen ions, right. So if you get to see this kind of reaction occurring, that means it is undergoing oxidation and it acts as anode, and the other cell which is attached to it will act as a cathode, right. But if in case we get to see this kind of reaction in this, that we get to see on cathode, that is the reduction, that is just opposite to it, that if we get to see that these hydrogen ions just combine to form hydrogen gas, that means they show reduction, and we know that the side which show reduction just act as cathode. So there is a possibility that when we connect this reference electrode with any other cell, it may undergo this reaction or it may undergo this reaction, right. So we will just see that if it is occurring this if it is undergoing this SHE is undergoing this kind of reaction, that means it is undergoing oxidation. That means this is acting as a anode, and the other cell which is attached is acting as a cathode, that we can separate that cell and use in any other couple, right. And if we get to see that this SHE, this kind of reaction is occurring for SHE, that means it is undergoing reduction. That means it acts as a cathode, and the cell which is attached to it may be acting as an anode. So we can just detach the combination and we can use in any other couple, or you can say in any other case, right. And one more thing you get to know, because we will be needing the relative value for the EMF, right. So you should know, and you have to just cling to this fact that the EMF value for this SHE is arbitrarily taken as 0, right. So the EMF for this SHE is decided to be 0. So when you have a combination of this SHE with any other cell, and whatever reading you are having for the EMF is actually the reading of that cell only, because this is actually the EMF for this cell is actually a 0, right. So that means the whole reading which you are going to get in the combination when you are attaching this SHE with some other cell, that is going to be the value for that one, the other cell only, right. It is not for this, because its value is taken as 0, right. One more thing you need to know, that whenever the oxidation is taking place, whenever the oxidation is taking place or where the reduction is taking place, right? So electrode potential or you can say the oxidation electrode potential value is always taken as negative, and for the reduction for the oxidation electrode potential is always taken as negative, and for the reduction it is always taken as positive. So we'll be just using the terms also, and I'll be showing you with an example that how this the standard hydrogen electrode is used to calculate the electrode potential of any other cell.